Okay, so now we want to move on to tree diagrams. We want to talk about tree diagrams. So we're going to use this example to show how we can draw a tree diagram and how we can use it to make our calculations. So for example, a bag contains 4 red balls and 3 green balls. So that's 7 balls in total, 4 plus 3. 4 red, 3 are green. If Tabo picks 2 balls at random without replacement, find the probability that both the balls that he picks are red, or find the probability that one is green. So the first thing we need to do here is, I'm going to go back a little bit. We have got this little phrase here, without replacement. Now, there are 2 ways we can analyze this. We can analyze this with replacement, or we can analyze this without replacement. And more commonly or more sensibly, it's without replacement. When Tabo is picking with replacement, if he picks the first ball, he's going to put it back, or he's going to replace it before picking the second ball. But if Tabo is picking without replacement, when he picks the first ball, he does not return it. By the time he picks the second ball, there's 1 ball missing, okay? So 1 ball is missing because he's picked 1. So that's the situation we have here. We have a situation where the number of balls decreases after the first pick. So let's just have a general tree diagram to show what happens there. Now, we know he's picking twice. So the first thing we need to do is just draw 2 straight lines, one for the first pick. That's the first line for the first pick, and then one for the second pick. And then you draw that. So that's the first step to drawing a tree diagram. Just 2 lines and make dashed lines there. Now, what we need to understand, on the first pick, maybe let me use orange, right? Tabo can either get a red ball or a green ball. So for the first pick, I draw 2 branches. One branch showing a possibility of getting a red, and another branch showing the possibility of getting a green. If Tabo picks a red ball on the first pick, he can go on to pick another red, or he can change and pick a green, right? If Tabo picks a green ball on the first pick, he can go on to pick another green, or he can change and pick a red there. So what happens is that we can have different combinations as the final outcome. He can pick red and red to get 2 reds. He can pick red, then green to get red, green. He can pick green, then red to get green, then red. Or he can pick green and green to get 2 greens there. So just highlight the greens to make sure we see all the greens. Okay, there's the greens. Highlight all the greens, and then highlight all the reds. You don't need to do this in the actual questions. I'm just doing this to make it clear where the reds are. Okay, so that's our tree diagram there. Now let's go to our first pick. The first time Tabo is picking, right, there are 7 balls in our basket there. Okay, so this is our basket here, and Tabo is going to pick. Now we see that we have 4 red balls and 3 green balls. So the probability of picking a red one there is 4 over 7. The probability of picking green is 3 over 7. So probability of picking red is 4 over 7. I write it on the branch moving towards red. and the probability of picking a green is 3 over 7. So I write that on the branch that's going towards the green. Now, remember what we said. We said that we are looking at a situation without replacement. So after the first pick, one ball goes missing. Now, there are two different possibilities. The ball that goes missing could be red or it could be green. So we look at these situations separately. If Tabo picks a red ball on the first instance, right, it means one of these red balls is going to go missing. If one of these red balls goes missing, it means he's left with only 3 red balls and 3 green balls. So now there's a total of 6 balls, 3 red, 3 green. So the probabilities change. The probability of picking red becomes 3 over 6 because there's only 3 red balls left out of a total of 6. And the probability of picking green becomes 3 over 6. There are still 3 green balls, but now the total is down to 6. Now let's look at a situation where the first pick is not red, but is green. If the first pick is green, it means one of these green balls goes missing, leaving us with 2 green and 4 red. So if there's 2 green, 4 red, probability of picking red is 4 over 6. Probability of picking green is 2 over 6. So probability of picking red becomes 4 over 6, and probability of picking green becomes 2 over 6. So this is what the tree diagram looks like when it's complete, right? But now let's go to the questions. The questions are: find the probability that both balls are red or the probability that one ball is green. So let's start with the first one. Both balls are red. You just go to these combinations and you look for a combination with 2 red, which is this one here. So that's the combination with 2 red. We want to find the probability of getting this combination there. So the probability of both red is equal to the probability of RR combination, right? So how did we get an R and R? We follow this path here, R and another R, right? So we get 4 over 7 times 3 over 6. That's the probability of getting R and R. It's 4 over 7 times 3 over 6. This gives you 4 times 3, 12. 7 times 6, 42. And then in lowest terms, that's going to give you 2 over 7. So the probability that both balls are red is ultimately 2 over 7. Now let's look at the other question. The other question is, what's the probability that one of the balls is green, right? What's the probability that one of the balls is green? Now we look for situations where we have a green ball, right? We have a green ball in that situation. We have a green ball in that situation. So the question said 1 green ball. So we won't include this because it has 2 green balls. We're only looking at situations where there's 1 green ball. So the first situation is RG and the second one is GR. Those are the 2 combinations. So the probability of 1 green will be equal to the probability of the RG combination, red then green, plus the probability of the green then red combination, because you have 1 green and 1 green in those combinations. For us to get RG is this one. We go 4 over 7 and 3 over 6, right? 4 over 7, 3 over 6. So that's 4 over 7 times 3 over 6 plus GR, green then red, is 3 over 7 times 4 over 6. 3 over 7 times 4 over 6. That's how you get to this point here. So 3 over 7 times 4 over 6. 3 over 7 times 4 over 6. So we just simplify that. 4 times 3, 12. 7 times 6, 42. Plus 4 times 3, 12. 7 times 6, 42. Add that, you get 24 over 42. In lowest terms, that's 4 over 7. So that's how you draw a tree diagram, and that's how you use a tree diagram in a situation where there's no replacement. So you can try the questions on tree diagrams.